To start the second half of Chapter 4, we're going to be looking at quadratics and reducing radicals, anything with square roots in them. First of all, we just need to be familiar with a couple terms. The radical sign is obviously your square root sign. The number that you see underneath the radical actually has a name that's called the radicand, in case you haven't heard that before. We have a couple properties that I want to give you. The square root of a times the square root of b. If you have two separate radicals, you are allowed to put those both underneath one radical and multiply those things together. For instance, if you had the square root of 9 times the square root of 2, you could put it together as the square root of 18. Or if you had the square root of 18, you could separate it into two different radicals. So that rule goes both directions. We also have something called the quotient property. Quotient, this first one is the product property, by the way. This one is the quotient property. So if you have one great big radical, you are allowed to split that up as two little baby radicals. And again, this rule goes both directions. If you see something written as two little guys and it helps you to put it as one great big radical instead, you're allowed to do that. Let me give you a quick example here. If you had square root of 2 over 25, you could write it as root 2 over root 25, and you could reduce then the 25 piece of it into just a 5. Okay, couple examples. Square root of 75. Square root of 75 is not a perfect square, so we need to break this up into two pieces. So this would be using our product property in reverse. What are two numbers that we could break this into, one of which must be a perfect square? Square root of 25 times the square root of 3. It doesn't do you any good to pick values that are not perfect squares. Your goal here is to try to reduce as much as possible. Square root of 25 is 5, so you have 5 root 3 as a reduced answer. If you had something like this one, square root of 7 times the square root of 35, before you go ahead and multiply those together, think about what your factors would be. I could change 35 into the square root of 7 and the square root of 5, and then I could put these two together as the square root of 49 and 5, which is then reducible very easily as 7 root 5. So without having to multiply 35 times 7 together, I could shuffle things around and come up with numbers that I could reduce. Fraction form, 100 over 169, purposely gave you values that are reducible here, just so you could see. Square root of 100, square root of 169 separated, 10/13. One thing we have to be careful of is that we cannot leave a radical in the denominator of any fraction. What you do is called rationalizing the denominator if you have something like that happen. So for instance, big square root of 2/15. When I write this as two separate radicals, square root of 2 over square root of 15. 15 is not a perfect square, nor does it have a factor in it that's a perfect square. So here is a case where I need to rationalize. I will multiply by whatever I see on the bottom. And if I do that on the bottom, I need to do that on the top as well. Square root of 2 times the square root of 15 gives me the square root of 30. Square root of 15 times another square root of 15 is the square root of 225, which just takes me right back down to 15. So now I have a rational number in the denominator. So this is legal. I can have a plain number in the bottom, but I can't have a radical. And the square root of 30 doesn't reduce any farther, so this one would be now finished. If you have a two-termed expression in the bottom, that would be called a binomial. If I have a binomial in the bottom and one of those is a radical, again, I have to rationalize that. And the way we rationalize is to multiply by something called a conjugate. A plus the square root of b has a conjugate pair. The conjugate pair is just the negative of whatever you started with. So a plus the square root of b has a conjugate pair of a minus the square root of b. So a sample for that would be something like 4 over 5 minus the square root of 2. I can't keep this binomial in the bottom, 5 minus the square root of 2. So I need to multiply by its conjugate pair. Not just the square root of 2, but the entire pair, its conjugate form. 5 plus the square root of 2. And whatever I do in the bottom, I need to do in the top. Now in the top, you don't necessarily need to do a distribution here, and I'll show you why. 4 parentheses 5 plus root 2. Now in the bottom, when we do our FOIL, 25 plus 5 root 2 minus 5 root 2, those two middle terms will always cancel each other out. And the only other thing I need to put in is right here. Negative root 2 times positive root 2 is just negative 2. And then 25 subtract 2 is 23. Now, we have to look to reduce. The reason I told you not to do the distribution here was because we want to look at these two numbers. Do these two numbers have anything in common that I can reduce? If not, then I don't have anything to reduce, and this is my final answer. 4 parentheses 5 plus root 2 all over 23. When you solve equations, we'll be looking at doing our square roots as well. So if we start with this first one, 2x squared minus 15 equals 65. Remember, you're solving for x, so you just need to start moving things to the other side. Add 15. 2x squared equals 80. X squared equals 40. How do I undo a square? Square root both sides. Square root and the square cancel each other out. I'm left with x equals. Now here it is very important that you remember that when you square root two sides, you have two answers, a positive and a negative square root of 40. Now you try to reduce. 4 and 10, the 4 will be our doable piece. Plus and minus 2 square root of 10. There's my two answers to this question. 1/3 x minus 4 squared equals 11. Times by 3, both sides. Let's get rid of that fraction. X minus 4 squared equals 33. Now I can square root both sides. That whole quantity, square root, cancel, cancel. X minus 4 equals, there's that plus and minus sign right away, square root of 33. And now, I need to add 4, but where do I add the 4? Here's where you have to be careful. 4 is a plain constant. Square root of 33 is a radical. You cannot add a plain number inside a radical. It usually sits in the front of your plus and minus sign. X equals 4 plus and minus the square root of 33. And that is how you leave your answer. 4 plus or minus square root of 33. One more down here on the bottom. 3 parentheses x minus 2 squared equals 40. Divide the 3. X minus 2 squared equals 40 over 3. Square root, both sides. Don't do 40 over 3 as a decimal. Leave it as a fraction. Square root both sides. X minus 2 equals plus and minus big square root 40 over 3. Can't leave a radical in the bottom. We're going to have to rationalize this. Times by root 3 over root 3. Square root of 120 over just plain 3. So now I've got x minus 2 equals plus and minus square root 120, square root of 120 over 3. Now I'm going to have to reduce 120. Let's move that up here. Square root of 120. What can I take out of that? Square root 4, square root 30. 4 is probably the largest perfect square inside of that, which would just be 2 root 30. So I've got, what was in the front? We've got this. X minus 2 equals plus and minus 2 root 30 all over 3. And now my last step is to add 2 to both sides. And where do we add that 2? In front of the plus and minus. 2 plus and minus 2 root 30 all over 3. There you go. Strange looking answers, but yes, that's how some of them turn out. Okay, we've got a word problem here. Dropping the equation, this is where gravity only is going to kick in. You're dropping the equation. This is one of them that you're going to need to add to your cheat sheet. Negative 16t squared plus h sub 0. T again refers to time. H sub 0 is the initial drop height. Where are you standing when you drop the object? Y will be the ending height. Typically the ending height is going to be the ground. And since you're not up in the air at all, that ground represents y equals 0. So a lot of times you're going to be putting a 0 right there where y goes. So for instance, we drop an object from 240 feet. How long until it hits the ground? So let's go to our equation. Y equals negative 16t squared plus, I'll put in our original h sub 0. There. Negative 16t squared plus h sub 0. All right, how long until it hits the ground? The ground represents 0, so I can put 0 right here. Negative 16t squared plus, now I can put in my initial drop height. I'm at 240. I need to solve for t. We can move our negative 16 over here. 16t squared equals 240. Divide by 16. T squared equals 15. Square root both sides. Cancel, cancel. T equals, I get both a positive and a negative all the time, positive and negative, square root of 15. Now, in the context of this word problem, we're trying to solve for time. Time is in seconds. Can you have negative seconds? No. We've got an extraneous root here. The negative is crossed off. So my answer will be time is the square root of 15. You can actually get that approximate decimal for this one, 3.8. Usually with word problems, you're allowed to go ahead and get an approximate decimal answer. 3.8 seconds. How much time it takes for the object to hit the ground. Please make sure you get that equation into your cheat sheet for your final exam, the drop height. Okay, that's it for section 4.5, solving your equations and word problems using square roots to help you.